Good day, everyone. Oliver White here, your faithful newsletter guy and your host and moderator for today's webinar. Joining us are none other than Jonas Bonér, creator of Akka, CTO of TypeSafe and jazz aficionado, as well as Jamie Allen, an expert in reactive design patterns, Scala, and karaoke. Say hi, guys.
Hello,
Hello,
I'm
guys.
happy to be here.
While I introduce today's session, I humbly request your participation in a quick poll that's going to ask you about your phase of journey with regards to reactive system adoption. This will fill the screen for about a minute or so. So while you answer this quick question, you may remember that last summer we launched a survey called Reactive Revealed, and an astounding 3,060 people responded to the call, which is my personal best. Giving us a really excellent sample population of people working on the JVM. So today, you lucky attendees are going to get the first glimpse of the data taken from these 3,000 plus responses. However, you won't see everything presented in the full report today. The full report with analysis and content and additional data points will be released tomorrow. However, as always, in addition to the slides and the recording of this webinar, I'll make sure that you all get a link to the report too. So I asked Jonas and Jamie to share their experiences and opinions when it comes to the results, namely on big questions like, what kind of perceptions do respondents have about reactive? When do people predict that successful enterprises, in addition to their own organization, will finally adopt reactive systems? How does the phase of going reactive influence the usage of microservices-based architectures and fast data systems? What are the specific tools and technologies preferred by respondents working with microservices and fast data systems, and so on? So if you have any questions, please put them into the questions tab in the GoToWebinar control panel. As I wrote, I'm not going to be able to field the questions too well because I'll be actually moderating and talking a lot. So please feel free to email me at oliver@typesafe.com. And as always, a big shout out goes to our happy subscribers, 91.54% of whom report extreme happiness with their TypeSafe subscription. Well, without any more talking, let me switch over to my screen here. And guys, do let me know if I'm doing it properly. Oops, 1 second. Okay, I should be sharing my main screen now and going into full screen mode. Jonas and Jamie, do you guys see my screen okay?
Yes, I do.
All right. So the title of this report is Going Reactive 2016, How Microservices and Fast Data Are Driving Mainstream Adoption of Reactive Systems. The first thing that we'll start with is let's see who were the respondents. As I said, we had over 3,000 respond to the call, and ranging from across 28 industries. A couple quick stats about the report. As I said, 3,060 total respondents. We had 62 tools and technologies included, and I'm sure we could have included 5,000 more. 28 different industries were represented. The survey was a total of 20 questions, and we have a 2% margin of error at a 95% confidence interval. If anybody knows what that means, please tell me. Just kidding. So let's look at the respondents. As you can see, 59% of our survey respondents are in the development area of job role. 24% architect, 10% management, CIO, CTO, a 4% other, and a small fraction of DevOps. Now, in previous surveys that I've done, I haven't seen such a large segment of non-developers. So if you see 24 and 10, we've got actually about a third, just over a third of respondents that are not writing code on a daily basis. And I think it's great that we got to see some of their perspectives too. When we look at industry of operation, we see a pretty reasonable split. These are the top 8 industries represented, and the rest has between 4 and 3%, 2%. However, technology at 21% is number 1, followed by financial services, online services, consulting, business services, telecommunications, government, military, and media. So now let's get into the meat of the matter. And this is where I'll be asking Jonas and Jamie to kind of chime in and share some of their views. One of the first areas that we wanted to look at is are reactive systems actually being adopted, and how do people feel about that? We define reactive systems as starting from a message-driven foundation through which the form of the system can bring on resiliency and elasticity, ultimately providing the business value of a consistently responsive system. Actually, Jonas, as one of the authors of the Reactive Manifesto, would you like to chime in here and fill in a little?
Yeah, sure. I think you said it pretty well. I think it's that. So then, I don't really know if there's that much to add. What everyone wants is really, a fully responsive system in terms of being responsive both, under heavy load, meaning that the system needs to be able to take more advantage of the use of the resources given to it, like both scale up and down. So to minimize energy and energy costs and so on.
Okay.
And the system also need to be responsive in terms of under the face of failure and when things start to go haywire, and being able to respond in a timely fashion using either graceful degradation, back pressure mechanisms, or ultimately sort of be able to heal the system itself. And as you said, I truly believe that the only way to get these three core traits is by basing it on a message-driven core. That gives you the asynchronous boundary between components. That gives you both, mobility before the components to scale out, and the resilience, and like we can contain the failure, and have a way of reporting it up the hierarchy to whoever might be interested in doing something about it.
Yeah, thanks for adding that context. We have a lot of good content on reactive. So we asked people what did they think about reactive. And starting from the left, we see that 5% of people gave oh my God, not reactive again. Another 12 said enjoying buzz, but that's probably it. But 83% of respondents, which is 4 in 5 people, said it's either totally important and something we needed yesterday, or it's gaining momentum and we should start looking into it soon. Jamie, you've been in this area for a while. Have you seen anything on the ground in trainings or talking with people at conferences that kind of shows this trend?
Yeah, I definitely have. One of the things about it that's been fascinating to watch is that there was an initial belief that the way we're doing it now is already meeting these requirements, is already satisfying this desire. And there was a little bit of, I wouldn't say pushback, just a little bit of skepticism that this is something that's required. But I think one of the things that's really changed for people in the past 2 to 3 years is simply the amount of connections they need to support, whether it's people who are talking through their browser, people that are connecting through a Fitbit, an iPad, a phone, all the different kinds of your car, your refrigerator. All of these things are now connections that are delivering data to you on a regular basis. And businesses are now accepting that they don't have the ability to write software that can withstand varying traffic from all of these different endpoints. So, we've seen a lot of people who before, I think, were saying, I don't really need to take this approach, but now saying, yes, I do. And then also, with all of this data coming in, how am I going to get value from it quickly? That's been a real driver for us.
Great, thank you. The next slide was a fun question for us because we wanted to, we split it up and asked respondents when they thought most successful enterprises would adopt reactive systems. And the following question was, when do you believe your organization will adopt reactive systems? So what we see is that the already adopted group on the left are pretty much neck and neck, and the same for those that are suggesting that by the end of next year, 2016, that reactive system adoption will have taken place. Where we see a real gain is in 2018, where we see 41% expecting most successful enterprises to have adopted reactive systems. This brings a total of 80%. 80% of respondents believe that most successful enterprises will have adopted reactive systems by 2018. And we actually see it a little bit lower for their own organization. And whether that's, guys, do you think that's something about kind of maintaining expectations or?
I think it has as much to do with that, or as a lot of organizations already have a strategic plan, right? And it doesn't go out just a single year. They've got an idea for when they're going to have to replace systems, when systems are going to require new versions and stuff like that, and they've already got this staged out for several years. So I think this is reflective whenever people are talking about their own organization. Well, we already have this plan.
Mm-hmm. So if 80% of respondents, and in fact, if we go back, we can see that, let me think, that should be about 69% of respondents believe that their organization will have gone reactive, let's say, by 2018. We wanted to know what do they think the main drivers of the main benefits of going reactive are, and these were the five choices, and we see that scalability is actually in the number one role, but not by any significant majority, and in fact, it's still a minority, followed by resilience. And this actually speaks, I believe, Jonas, back to the four tenets of the Reactive Manifesto: message-driven, elastic, resilient, and responsive. And then for kind of in the third category, all within very close range, we see the need to modernize, which is what Jamie just discussed, velocity of rollouts and development velocity, as well as efficiency, which Jamie also just touched on, and as well as Jonas, in terms of not just scaling out and throwing a bunch of servers everywhere, but being able to scale it back in when the need is low. Do you guys have any comments on this this graph here?
No, I think it's sort of what I would expect. As Jamie just said, we have with mobile and Internet of Things, and you know, most applications today are put on the internet, and they get exposed to not just hundreds or thousands, but actually hundreds of thousands of users, sometimes even millions. So I mean, scalability is one of the key benefits, naturally, that reactive principles gives you, and even more so elasticity and being able to like vary the scalability according to the load, and that's where we've seen the efficiency, the 15% here, I guess, as well. What I sort of would have liked to see, though, is that the resilience sort of percentage would have been the highest, because that's sort of my pet peeve, and what I really think people really need to think more about, and as I've said in my latest talk, without resilience, nothing else really matters. It doesn't matter if your application is scalable if it's not up, if it's not resilient. And also, historically, this has been the thing, I believe, that we talk about in reactive systems, that people have historically sort of hand-waved and it's sort of not actually architected around, but instead just bolted onto the application. But having 22% seeing it as something really valuable is definitely a sort of an increase from most like JE applications and historic enterprise applications that I've been part building in some years ago. So
right,
I think that trend is going in the right direction.
Mm-hmm. Yeah, I agree. In fact, respondents were asked to choose their number one favorite benefit. So these are the people who selected resilience are all about resilience in that case.
Yeah, I see.
You know what, Oliver? One thing I think that's very important to what Jonas was saying there is that we're really good at thinking about the things that can go right in our system, but we're not as developers, myself included, really great at modeling the way things can go wrong, whether that's through the application layer and our domain, or things at the hardware layer that could go wrong. And I think the uptick in resilience here is largely built around the fact that people are now moving towards systems that are being deployed in multiple servers. Not many things are being put out there as well, that's not true. Less systems are being put out there as monoliths that are being deployed. It's just one thing out there, maybe a couple of things. Now you're talking about multiple instances of an application that have to possibly coordinate in some way. And people need to think about resilience more. But as developers, how are we going to start doing that in a way that allows us to model failure and know that we're able to withstand all of the things that can go wrong in an application, both at the domain and the hardware level?
Yeah, exactly. As Jamie said, I mean, if you scale out, I mean, if your top is the 31%, then you just have to think about resilience, because scaling out implies having a network between your nodes, and then a network is, as we all know, inherently unreliable. It will drop packets, it will reorder them, it will duplicate them, and it will do all kinds of weirdness to the receiving end. I mean, of the request. So it needs to be ready to fail gracefully and recover.
Yeah, definitely. Great. Well, let's move on. Of course, there's it's not all rainbows and unicorns and all that good jazz, but we wanted to figure out, where do people see the potential blockers of going reactive? And again, we see a very wide split here. This was not an exclusive option, so people were allowed to choose as many as they wanted, which is, as you can tell, adds up to greater than 100. Starting from the left, it will take too long to do, and finding new employees to work with these systems, these were at the bottom of the list. So this kind of speaks to the concept that a lot of overhead, or rather some mental overhead, will be involved to go reactive. Towards the middle, between 21 and 26%, we see a happy 1 in 5 respondents are saying there's no barriers and we're going for it, followed by a lack of interest by staff. And that might also reflect in the far left category, will take too long to do. In terms of the top 3 blockers, we see that at 26%, there's not enough support at the top of the organization. 27% refers to a disruption of existing activities. Things would come to a halt with what they're working on. They'd have to kind of start on something brand new. The context change would be disruptive. And the number one blocker for respondents was the need to retrain existing staff to use new technologies and methodologies. So Jonas and Jamie, a lot of these kind of overlap for me, but I recognize that there's some distinctions between that. What do you think about the need to retrain existing staff to use these new technologies and practices?
Yeah, I mean, I think that's something. You can go ahead, Jamie. You've been running training more than I have, so.
Yeah, well, the crazy thing about this is, the way we tend to look at technology or trainings is that, I need to train my people on technology. But that isn't so much the case. Is there needs to be a fundamental understanding of what we're talking about when we're saying asynchronous, non-blocking, forking, joining, concurrency versus parallelism, and how we avoid it. What are the best practices around this that are agnostic to the fundamental technologies being used, right? It doesn't matter the language I'm writing in. It doesn't matter what I'm deploying on, whether I'm using a container. None of that is relevant to the core principles of building systems that scale well. So one of the things that I think around training, and we do see this with customers who say, look, there are all these things that I want my team to understand, but I don't want them to necessarily learn a new language yet, right? Because we'll use Akka with Java or Play framework with Java. But now technologies are starting to move in a place where you do get benefit from a language. For example, using Spark with Scala versus Java, there is fundamental and tangible benefit in doing so, right? Around being able to interact with the data in a live session as opposed to just being able to run batch jobs. So, starting with the idea that people need to understand these core concepts, and then moving into how do the technologies best leverage it in a way that my people can do so quickly, is a really important path people need to be able to take. And if a company says, well, I'm just going to hire everybody I need, that's not going to be cost effective. They've got a team of people that are already talented and working and understand their domain. So, investing in training, whatever technologies you're using, is a very important step. And I know this because I started out, for example, with Scala and Actors, and I had nobody teaching me. And, I had to figure it all out. Here's some books. Good luck. I remember doing a podcast with Jonas back in 2010 or something like that, and he was talking about higher level abstractions over locks, and I had no idea what he was talking about, even though I was writing Actors.
It's a very different picture now, Jamie. I'm sure you can teach me a bunch.
What about not enough support at the top of the organization?
Yeah, I guess that is a fact. It's sometimes, some of these things are usually driven from the grassroots. It is the developers that see the pain, and they want to work more efficiently and using better tools. But it's always like, I don't think that's sort of tied to reactive when it comes. It's sort of we have this problem when it comes to all sort of revolutions or all new ways of thinking. If it's like core by SOA or EJBs or whatever, there will always be a need to sell that in to upper management. And I believe the way to do it is to phrase in a way that we can emphasize on the high level values, like resource efficiency, actually getting real about cloud computing for once. Back to utility computing, almost actually pay as you go and be as efficient as absolutely possible. And what I always stress is resilience. No one wants to lose money by having your servers being down. That's something that everyone can understand. Regardless which role they have in the business. So I think for developers, it's just trying to find the right angle and bring it down into dollars cost or dollars lost. So
yeah, that's a great point. And I do like that 21% are claiming no barriers and that they're going for it. So there's kind of a silver lining to this. Well, let's check out the next stat. One of the questions was around who do you believe in your organization is actually responsible for helping initiate changes, either in terms of new tooling for development teams or new methodologies, etc. And what we saw, the stats revealed that 52% of respondents believe that developers are at the like you said, Jonas, the grassroots level. And not only are they at the grassroots level, but they believe that they should be leading the way. Or rather, over half of respondents believe that developers should be kind of taking the first step, followed by architects at 31%, and then the CTO in third place, with 11% of respondents believing that the person in this role should be the visionary. Interestingly, as an aside, the executive board of an organization as a whole was only selected by 2% of respondents. So, Jamie,
yeah, I'm wondering. These numbers sort of seem to reflect the people that have actually taken the service. I'm wondering if everyone says that they think that I should be the one that leads the way.
Yeah. Well, I can't remember who referred to developers as the new kingmakers. I know I'm having a brain interruption at the moment. But I think that respondents who took this survey also believe that developers are indeed the kingmakers, and architects are definitely in there as well at a much kind of smaller population. Skipping forward, this is an interesting graph to pause on for a second. Like the poll I just presented at the beginning of the webinar, we also asked people to describe their phase of journey in terms of going reactive. So starting at the top, 4% are saying that reactive is not actually applicable to them. But that leaves 96% of the 3,060 who are involved in reactive at some level. Going clockwise, we see that just under 1 in 5 respondents are only starting to look into the topic. Perhaps this survey was the first introduction they've had to reactive, but I have a feeling that it had been, they've seen it, and now it's time to look in. So we're referring to that 19% as the kind of entry-level group. Continuing clockwise, we see that a total of 43% we can consider active starters. The largest single group of respondents are learning or doing research about reactive systems, and a further 14% are building a prototype. Now, around between I guess 8 o'clock and midnight on the clock, we see our power users. Power users are those respondents that indicated that they're developing a production application. They're getting paid to write code that for a reactive system that will be going into production. And then 18% are actually running a production application. So 1/3, just over 1/3 of all respondents are power users that are building and deploying reactive systems in production. Oh, sorry for the noise. I'm not sure if this is just kind of an indication of who was involved in the survey. So, like I said, about 1/3 are actively developing and are running a production application. 43% are active starters. They're working on hobby projects, prototypes. They're doing research. And just under 20% are just starting to look into the topic. So skipping forward, this is, and we'll get back to that grouping a little later. The next slide shows a question. If you were going to ask the question, if you were going to go reactive today, how would you do it? We see that the largest group of respondents believe that refactoring their legacy system module by module is the best approach. So, Jonas, could you speak to that group?
Yeah, sure. I mean, this sort of, I think, fits very well with my sort of experience being out there talking to customers. That sort of they usually sort of go about this by sort of adopting microservices-based architecture. So first refactor the legacy system into microservices, perhaps still using legacy techniques, and then start swapping out sort of re-implementing then service by service. And it's very important that you do this like vertically, so you really get the benefits of being reactive from top to bottom, and of course then start with the most highly loaded services, or the ones that just can't go down, and so on. So I really believe when it comes to legacy systems, that is probably the most used and best approach.
Okay.
I think that there's also a certain amount of risk that has to be taken into account here. A lot of the large organizations I've been working with, whether it's a really large consumer electronics company in Cupertino, or a company like a really huge hotel chain, they take different approaches depending on their risk profile. How important is this to their business? How much do they need to change right away? In the case of the consumer electronics company, some of the projects that engaged have involved a very staged approach, where they've said, we're going to do a POC first, and then we're going to replace a small component that's very deeply embedded in our pipeline of work that gets done whenever we release a product, and then we're going to go full scale, right? And they have to meet all of these gates, but they're only doing it in very targeted ways with that throughout their infrastructure. They're not trying to roll out a really massive piece. Whereas the hotel chain is taking a much different approach, where they're saying, hey, we're going to replace our entire reservation system all at once, and in doing so, become much more efficient and save money. Just a POC they did with Akka Streams that they're running with a very large consulting firm resulted in a 75% decrease in the amount of resources being used, and a 6.5 times increase in the amount of throughput they were getting through the system with no optimization yet. And they were just thrilled. And now they're going full bore. They see the value to it, and are just attacking it ravenously. So it depends on the organization and the risk that they're willing to take on.
Indeed. Moving forward on the graph a little bit, we see basically about the same amount of people, 24 and 23%, selected two options. One, completely rewrite a new project to eventually replace the legacy system. And the second is shave the existing stack and replace bottlenecks or APIs. And Jonas, I think that speaks to what you said when it comes to figuring out which systems simply can't go down, or which systems are the most problematic in terms of API stuff, for example, and start there.
Yeah, I think you have sort of these two different categories. Either you try to fix your current legacy system, or you go for the complete rewrite and you swap at some point. And thus, I think Jamie did a great job outlining the benefits of each one of these.
And the least popular approach is to create a greenfield front end and use a legacy back end. Now, we put that option in there because we'd actually seen this story occur with several of our partners. Jamie, can you elaborate slightly on that for a minute?
I'm sorry, I was just typing a response to a question. What was that again?
What a guy, such a multitasker. I was saying that the final category at 12% is the option to create a greenfield front end using a legacy back end, and that we included that option in the survey because we've seen this several times.
Yes, absolutely.
Among our own customers, and we wanted to see if that was actually an option.
Yeah, I think this gets back to, in a lot of cases, companies have invested a tremendous amount of resources into legacy platforms and systems that they can't be fully replaced right away. A really good example is when you hear Kevin Weber talk about his experience at Walmart, where they had these 7-second page load times, and that was just unacceptable to their business. They were losing customers hand over fist. They were falling over every time there was a burst of traffic. And what they found they could do to minimize the cost of trying to go reactive, but maximize the value of it, was to replace certain parts of their system and still rely on some of the legacy back-end packages that were already purchased. So there was no way they were going to get to page load times that were sub-second, knowing that they had these legacy systems that were still going to cause them to have higher latency than they'd expect. But they could minimize it to the point where they reduced their page load time down, I think, to within 15. I think they were 15% of what they were doing before, so an 85% increase in page load time, with the legacy systems still behind it, right? Just being able to manage all the resources as far as threading, and a request comes in, I've got to get data from multiple sources. How do I do that most efficiently? Return that data and aggregate it. Was a tremendous benefit to them, and kept them from also being overwhelmed. So that was really impressive. Right. And that's all the cost benefit factors that organizations have to take into account. It's very rare that you can say, let's just wipe the slate clean, right? That just doesn't happen very often.
And I think that these results speak to that there isn't one way of going reactive. There's definitely a large distribution among methods and techniques.
Yeah.
So
And
yeah.
interestingly, the monetary cost here of using less servers and stuff is substantial. But in Walmart's case, it also led to $1 billion increase in business tied directly to deploying a new version that was able to stay up and serve customers in a way that they were stickier on their site. $1 billion is, real. Any business.
Don't we all know that? So that brings us to the kind of the summary of this first section here, and I'll probably try to speed it up a little bit as we go. But this was an important section to kind of show you where people are at when it comes with their predictions, the actions that they've taken so far. Here's kind of the roundup. 83% say that reactive demands attention. 80% expect full enterprise adoption by 2018. And again, these are the most successful enterprises. I should probably update this graph. 43% are already researching and prototyping, and another 34% are actually building and deploying production systems. These are the active starters and the power users groups that I mentioned before. So these are what people are saying. These are what people are doing. Let's look to see what they're actually doing. And the first place we're going to look at are microservices. So it seems as though the industry favorite term is microservices, but I know that the three of us have definitely discussed before different kind of terminology to describe that, such as decoupled services, or Jonas, I think you mentioned something like SOA done right, and this is what we've heard from people. So let's jump into microservices adoption by phase of journey. Again, going back to the previous graph that we saw, where it described the groups that are involved in going reactive in some degree. We see a pretty cool mountain graph here, where 16% of respondents who are just learning about reactive are working with reactive systems. 28% of those that are researching and prototyping are working with reactive systems, but then we see a massive increase to 50% of those respondents who are building and deploying reactive systems, these power users. 50% microservices adoption. What do you guys think about this?
Yeah, I'm not that surprised. Actually, I think microservices, when you look at it, is really one of the sort of best sort of applications or usages of the reactive principles. I believe. I've always looked like in an actor-based system in Akka and even in Erlang and all the systems that are sort of built. All the applications that are built using the microservices. Also, the reactive principles are really microservices. Even before the term was starting to be used. I think in 2012 or something like that. And our customers, they have like constantly been referring to their architecture as microservices based. As I think a majority of them are using that, and I think microservices sort of provide a sort of a simpler view towards reactive in a way. It's more opinionated. It's more guardrailed in a way, and it's less options usually in the frameworks that implement that in microservices, or that allows you to do microservices. But a well done microservices framework or platform should give you all the benefits of reactive, I believe, and a lot of the traits are similar. I mean, isolation is a hallmark of reactive systems. That's something that we see that people talk about microservices really learn to love, and single responsibility principle. I mean, do one thing and one thing right. That's the way I've been writing actors-based systems for years, and it's a really good pattern there as well, and the list goes on. So I think that there's really strong correlation, and I simply view it as a nice entry, a gateway into building reactive systems. And sometimes just staying within the microservices domain is all you need, right? Because it gives you all the power that you actually need. But if you're building it on a really truly reactive platform, then you have the option of stepping down one level if you feel that the microservices framework is too constrained. So I'm not surprised to see 50%, because that's really the way I view reactive and the way I view microservices.
Hey, Oliver, is it okay if I make this a little more concrete? I know that it's already 9:40, but the thing about microservices to me that's very difficult to wrap my head around is this abstract term. How do I take my system and make it microservice based? It just sounds like, pixie dust, right? And to me, I think one of the biggest drivers here is the fact that historically people have been building systems around a monolithic data store, right? A single data store that represents all of the data that is being written and all of the data that is being read. And maybe there's several of them inside of an organization, but there are all these monolithic stores that are representing all sorts of things that can be happening in an organization at any given point in time. And I think we're finding that that's just a scalability anti-pattern. And you have to deconstruct that monolith at the data level such that you've got data coming in, you have a way to capture it and put it somewhere, right? And that way it can be written really quickly. But then you also need to make it available to be read in a way that, makes sense quickly. You can't be performing expensive joins on the fly. And, we saw this at a large cable company I was working for in 2011, where every time somebody was using a remote control, they were trying to figure out, it's a web service call. What do they have the rights to watch? And it was an expensive join against this monolithic store. Well, what if we could just segment that off, that functionality, such that it was always available in buckets of data and a distributed cache view of what's available in that monolith? And then the real questions came around, well, how are we going to keep that in sync, right? Does it have to be event-based where things are going to come out of the database whenever a write takes place? And are we going to propagate that into the cache? And what happens if it fails or falls off somewhere? That's not reactive at all. And instead, you have to get into patterns of, what's acceptable to me as far as the latency of my data being up to date with that write. Now it's about how do I get that data in sync as quickly as possible, but also deal with the fact that I may not receive every event. So that can be done. It's just a matter of saying, I'm constantly recalculating the data that's in my cache. And in doing so, the business now has a live view with the worst case scenario of, whatever choice they make about that consistency level, that eventual consistency with the write store. And now you can split your entire architecture apart into what data do I need to make available to the various components of my systems, the various clients of my system. And in doing so, make really targeted choices that lower the cost as far as page load times or latency in response.
And this is actually something we get to in just a few more slides. So thanks for making it. No, Jamie, this is exactly why I wanted you guys to join, because I think that your perspective and your experience is really valuable in looking at these new stats. Here's an interesting one, and I'll try to kind of rapidly go through so that we do have time for a few Q&A. We looked at, so MSA is microservices-based architectures. There's obviously content related to this in the full report, which I mentioned will be sent to you in the next couple days. What we're looking at is microservices use of Java and Scala. And in the dotted lines, we see the averages for all respondents. So starting at the bottom, we see that Java 8 and Scala both rise around the same level, and they both have a significant, statistically significant increase in adoption when it comes to microservices-based architectures. But what's also interesting to note is that usage of Java 7 or lower drops rather dramatically as well, from 41% average to 30% of microservices-based architectures. So that's just something interesting to note. Here's the next three slides are all kind of similar. This is where some really cool data shows up, in my opinion, guys. And this is which technologies out there see significant increases in adoption when we look at the microservices group. So as I said, we had 62 tools on there, and in the full report, you'll see content for all of that and what people chose. Just a quick secret for you: IntelliJ IDEA is the #1 used tool of any technology in the survey. So there's a tidbit for you. So we looked at not only the average, all respondents, as well as those saying that their system is microservices based, but we also looked at the adoption levels of not microservices based systems. So those respondents that are not using microservices based, which is about 50, which is, I remember correctly, 59% of all respondents. So we have here ops, infra, DevOps technologies in use with microservices. All of the tools that are shown here saw significant increases in adoption. So not just a couple percent, large increases in adoption. For Amazon EC2, we see that go from 40% to 52% within microservices-based architectures, or MSA. Docker goes from 34% to 47% in MSA. And Mesos goes from 7% to 13%, which is not as massively adopted as Amazon or Docker, but the increase in itself is significant. Continuing on to big, fast data technologies in use with microservices, we saw Cassandra, Kafka, and Spark have significant increases. Cassandra goes from 18% to 28% in MSA. Kafka goes from 17 to 27% in MSA, and Spark goes from 22% of all respondents to 30% of MSA. And we talk about Spark a little bit more later. I'll just go to the next ones to get it all out, and then we can pause for a second. When it comes to developer technologies, we see that Akka is Jonas, you'll be happy to see that Akka is strongly embraced among microservices-based architectures. If I remember correctly, it's the #1 tool in terms of percentage use among microservices-based architectures. And that one goes from 43% to 59%. And Play Framework, which was 30% of all respondents, goes to 40% in MSA. Now, we saw something interesting here, and we do admit that there's some bias present in all surveys, and most likely the people that follow TypeSafe and our contacts are more likely to respond to the call for a survey. But this one has to do with Spring and Play with microservices. When we look at all respondents, we see that they're neck and neck. They're statistically the same. 30% of using Play and 29% using Spring. But when we look at the microservices-based architectures, we see that Play increases from 30% to 40%, and Spring drops a bit from 29% to 26%. And I'm not going to sit here much longer, but because we could probably talk about this all day, guys. But the fact of the matter is that we just saw a list of tools that the only tools out of the 62 we showed that had significant increases in usage. And we'll come back around to that in a minute. So Jamie, you were just talking about the need to not have a monolithic data structure, to be able to access different data points at different times and have that be very responsive and fast moving. So this brings us to a section called Fast Data and Reactive Systems. And we use the term here, data in motion, as opposed to data at rest, which is something that we've talked about. I believe Dean Wampler's recent white paper describes this in more detail. Again, we take a look at, so we're actually looking at Apache Spark here. So whereas the previous section was based on an architectural concept, when it comes to data streams and very high performance processing of data, Apache Spark, more than any tool, I think you guys would agree, has made some enormous waves. And we actually released a survey earlier in 2015 only on Spark. So we wanted to check in and kind of see what Spark is up to. And again, along with the microservices adoption along the phase of journey, we see the usage of Spark increases, not so dramatically like microservices. But we do see a consistent increase in adoption from the just learning phase to the researching and prototyping phase to the building and deploying phase. So we do see a nice positive trend there. So I think Dean would be one of the first to say that there really isn't necessarily a direct connection in many people's minds between microservices and Spark. So although we did see an increase in Spark usage among microservices-based architectures, the average was 22%, and here we see 30% of MSAs are using Spark. When we invert that, we see that 46% of Spark users have adopted microservices-based architectures. And that was very interesting to me because I also don't make the direct connection between, streaming data and Spark core running on top of Hadoop or another implementation and microservices. But in fact, Spark users have adopted microservices-based architectures almost at the same level as the power users, which were at a 50% adoption level. Guys, I'll pause here for a second. Would you like to share any comments?
Yeah, I think that in particular, the real question is how are they deploying Spark, right? Are they deploying Spark in a Hadoop context using a resource negotiator like Yarn?
That's the next slide.
Oh, well, okay.
Let's just go there. Let's just go there. Before that, we also asked about, we looked at Java and Scala usage with Spark. And again, we see a decrease in Java 7 or lower compared to the average, which is the dotted line. We see a reasonable increase for Java 8, but where we see the huge increases with Scala, which goes from 50% of all respondents to 76% of Spark users. Moving on from that, let me skip forward. So Jamie, this goes back to what you were talking about. Where is Spark being run, and how is this fast data reactive system implementation going? So in the full report, you'll see that overall adoption of Spark was at 22% for these respondents, and that Hadoop was at 16%. So we see that Spark is definitely here to stay. And when we look at the relationship between Spark and Hadoop, it's important to note that Spark is not replacing Hadoop. It is often being used to replace Hadoop MapReduce, which is one module in the overall Hadoop ecosystem, which is why we see 46% of Spark users are also using Hadoop. That leaves over half of them that are using Spark outside of Hadoop. And Jamie, this is just what you were talking about. Would you like to comment?
Yeah, it's really about the mode that they're using Spark in, whether they're using it in standalone mode or using it with Mesos. Either case, what they're really doing is making their data in motion available to the application layer. Whereas using Spark in a Yarn context means that you've got batch jobs you're basically running only. There is some blurring of these lines starting to take place with tools like Myriad, the Apache Myriad project that's in incubation, created by the MapR folks. It's fascinating to watch this bridging take place where you're no longer going to see a dedicated set of machines being used only for, batch data analysis jobs. Instead, you're going to see a lot more of the, I've got data in motion, and as I'm processing it using something like Spark Streaming or Flink or Samza or what have you, I'm getting that data through a pipeline of transformations. I'm putting it into some kind of store which makes it accessible, and my applications are able to give me information about that live, right? That's the transition we're seeing, and it's super exciting to watch. It's difficult right now sometimes as far as like the architecture goes. Is a lot of these tools are really nascent and they are growing maturity. We don't have these problems with things like Cassandra. We don't have these problems with things like Kafka. But a lot of companies don't have that same comfort level with a tool like Mesos. I think that Mesos is gaining adoption as people are realizing that it has been proven in an enterprise environment. Look at Apple, right? I could talk about this because Apple did a talk at the Mesos conference this year. About their usage of Mesos, right? It's just it's a very powerful tool underneath for resource management in a large scale deployment. So, you know, we're seeing a lot of new approaches, and in some cases, I mean, people are solving problems as we go. I mean, think about this. Spark as a tool is not built for multi-tenancy as far as people doing, a lot of queries against data. So one of our clients is a large hedge fund in New York. They're using Spark to ask questions of what's happening in the markets right now, and we need to be able to help them answer those questions. Well, how are we going to do that in a way where people can submit these queries to Spark, but also get the right priorities in place so that Spark isn't trying to do some job that isn't as important as this question I need an answer to right now, right? And you see, in particular, one company just open sourced a tool called Cook. Another fellow named Evan Chan has just been working on a job server built in Naka. A lot of people are thinking about how to make this data accessible quickly, right?
And I think that what you're talking about is the kind of broader. It's not just about Spark, but what we do know is that Spark is going to be used for these particular needs as part of a puzzle. It's not Spark alone, and this is why we're looking at this slide now. Again, we tried to identify those technologies that increase dramatically in usage among Spark users compared to the average. And we see an interesting overlap, as a matter of fact. Starting from the left, we see that Akka goes from 43% to 64% among Spark users. Amazon increases. Cassandra has a significant increase from 18% to 44%. And that is only beaten by, let's see, Hadoop, which goes from 16% in overall usage to 46% of Spark users. Again, that still says that over half of Spark users are running Spark outside of Hadoop. So the kind of infrastructure for that is definitely coming along. And Kafka, which goes from 17% to 49%. And if I can count, I believe that's the largest increase that we witness. Docker in the middle goes from 34% to 52%. And again, Mesos, which only had 7% of the average, has an even larger increase to 22%, which I believe is just over 3x. So what we see here is these again, this recipe, let's say, for fast data systems include these tools that have been selected by respondents that have considerably increased adoption levels. We just saw this slide. Wrapping it up, there's more to it in the report, as I mentioned, but I wanted to share this one slide because I think it shows a really great picture. And there's a typo on the bottom, which I need to fix. So what we wanted to look at, we see that in the middle, 50% of respondents are using Scala, 52% are using Java 8. And in fact, on the bottom, that should be 56%. We actually see Java 8 and Scala are being used together more than just individually. And to remark on the line above at the top, different versions of Java 8 and Java 7 or lower, for example, are even less likely to be used. Any comments, guys? We're almost at the end.
I think it makes sense. I mean, you use a language for what it does best, and Scala is a very data-centric language. Java can be a little bit more built around primitives with less abstractions. So, you use the language that makes sense for what you're trying to do, but then there's also the consideration of, I have a whole bunch of people who are doing Java work over here, and I have a team that is working with Spark and Scala, right? It makes sense for now.
All right. And that brings us to the 3 conclusions nicely wrapped up for busy readers. And this is kind of taken from the report. So we've seen a lot of interesting information presented in this report. And we've developed 3 conclusions that we believe the data points to. Reactive system adoption is going into the mainstream. We see that 83% of respondents believe that reactive at least demands attention soon. We see that just over 1/3 are actively building and deploying reactive systems in production. Over 40% have already gotten started either researching or building prototypes, and we see these trends leading in this direction. The second point is that reactive adoption is being driven by these two key trends. And one of them is the adoption of microservices-based architectures, which is an architectural decision, as we emphasize, and kind of fast data system architectures based namely on Apache Spark and the related tools around there. And it really comes down to these two technology trends that are really driving the adoption of reactive systems. And the final point is that we see an interesting cross-section of tools that have significant increases in adoption when we look at specific groups. So those that have adopted microservices-based architectures and those users that are building fast data systems based on Apache Spark and related tools, they've selected a prescription of tools and technologies, the logos of which you can see there. And while some of them don't cross over completely, we see that Akka, Amazon EC2, Cassandra, Docker, Kafka, Mesos, and Spark both see large increases in adoption when we look at the microservices-based architectures group as well as the fast data users, obviously Spark for the fast data users. And this is where we have it. So this is the final slide. Jonas and Jamie, what would you like to say about these last points here?
Yes, as I said before, I think that both microservices and fast data are two excellent or high-level applications of the reactive principles, like implementations, you might say, of the reactive principles, lenses, like into the reactive world, and these tools are just great tools that support you all the way through building microservices and fast data based applications, and they are, as we've already seen, but my experience also says that they are very often used together, microservices and fast data, and I think the whole world is going more and more towards data in motion, like streaming, and everything needs to be now, dealt with right now and fed back into the application. So I think we see more and more of this, like usage of Spark and Flink and these type of data streaming tools in conjunction with like platforms like Akka, and using like sort of databases that can actually deal with the load, like Cassandra, for example, and all this needs to be using isolation all the way down. So that's why Docker comes into play, and if you have enough large applications and enough Docker instances, then you need to rely on something like Mesos to orchestrate that and make sense of that at runtime. So I think it's all connected. I'm not that surprised.
I think there's also a growing awareness as organizations are looking into the ecosystem that they don't have to buy this web server, this application server anymore, right? But yes, tools are becoming much more specialized. There is no, here's two things that will solve all of your problems. It's much more, what are my problems and what are the best ways to solve them based upon the tooling that's out there. And organizations, even those that are the most stodgy, are finding that if they want to continue to do business in this environment, they have to adopt these approaches. Otherwise, they are going to get eaten.
The fast fish eats the slow fish, right?
It's not just our technologies. It's, these are the best of breed.
We see that almost all of them are open source as well, which is probably a future conversation.
Right, that's absolutely true.
With the exception of Amazon Web Services, every single one of these tools is open source and available to anybody who wants.
Java. Java's not 100%, so.
Okay. Well, that brings us to the end of the presentation, folks.